But let's rock and roll. Number 4, sometimes the identity helps. There's some helpful stuff in here. But you also want to go about multiplying these to simplify. This is not an equation. This is just, again, simplifying. The equal sign is misleading. I just want you to rewrite it. The benefit of multiplying this, if I make this sine of x over cosine of x, because we've decided that seems to be helpful, rewriting it in sine of cosine, 1 over sine of x. And when I distribute this sine over cosine, the tangent, so that we talk about, it looks like, you know, can you multiply those in there? I think it would be sine x over cosine of x. Okay. 1 over sine x. And then you distribute it to the other one. It's minus 1 times all that stuff. So don't forget the minus. It'd be easy to forget. This is okay. You can definitely cancel those signs. I'm sure you see that coming. But even after I cancel those, there's that whole fractional addition and subtraction thing. The cool thing is you do the same thing every single time you encounter it. It's real consistent. So I have 1 over cosine left on the left. Let me know if that bothers you, if you don't recognize it. I like that I'm in terms of sine and cosine because this is the next big tool we use a lot. When you have two fractions, find a common denominator if they don't already have one, and then add and subtract them. Put them together. These already have a common denominator, so this is kind of a nice entry point. I'm going to actually just say put these both over cosine of x and make it 1 minus sine of x.
How big are you on like adding x to the end of sine and stuff like that?
How big do you mean? Wait, say that one.
Like if we didn't have it on a test, like would you?
I don't get all excited about it, but it's good, yeah, to keep it on there. There's a time when it becomes important, but yeah, I won't come after you if you do. Try and remember. Do your best. It's a good call. 1 minus sine of x over cosine of x. Now this is the end result. This is a little different. I have to tell you, I'm going to go write the end result of this. Like, what did we just accomplish? We just accomplished writing this as 1 minus sine of x. Oh, poop. Sine of x, jumped on me, over cosine of x. Now, some of you might say, I don't think that looks any more simple. I would agree, by the way. This isn't a the word simplify is a misnomer. What you should be doing is we are in the process of rewriting things in different forms. And the reason this would be beneficial, I'll tell you again, just because I happen to have a ready reference. If I were asked in a calculus class to please take the integral of that expression, the one on the right, to me, is way easier and a lot better because I have a technique called U substitution that's actually really easy in the land of calculus that students go like, oh yeah, it's a U substitution. We like those. That one on the right is doable. The one on the left is not so fun. So rewriting things just makes it more accessible, makes your life easier. So this is a technique we would use to rewrite it. It's not simple. It's not easier. It's more conducive to the task at hand. So it's just rewriting. So this says multiply. It's just giving you an idea that you can write it in a different form. They're equivalent graphically. The other day when we were doing Desmos down in the lab, some of you found out that if you graph two things and they are equal to each other, they match. They make the same picture. Those two make the same picture if you graphed them in Desmos. One in part one and one in the second. They look exactly the same. That's so cool. I'll get to that in a minute, by the way. So, multiply again. This brings up something really nifty that's not on your sheet, but I think we'll add it. Multiply means distribute, so we're going to do that. We're going to answer that phone call, and it's going to get recorded. That's cool, too. Actually, you know what? We'll pause it.
Yeah, I was going to say.